Okay, in this video I'm going to tell you how to add and set up gear pairs in MechDesigner. So I've already set up a single crank that is rotating at a constant speed. I want this crank to drive another part which I'll put in a box about here with a fixed ratio, in other words through a gear pair. First I need to define a line on the base part which will link each gear center. Then I must add a dimension to this line. The gear pair will take control of this dimension to keep the center distance correct. Now I can add the part which will carry the driven gear. So I have a driving part, a driven part, a line which links their centers, and a dimension to control the center distance. These are all things needed by the gear pair. So now we are ready to add it. Click on the Add Gear Pair command and start selecting the elements needed. First, a line on the driving gear. Second, a line on the driven gear. Third, the center line. And then select the dimension of the center line. The sketch is automatically opened. Now the command can be completed by right-clicking or pressing the OK button. The gears will be drawn using the default setting. They should always be in perfect mesh. The center distance will be automatically adjusted to be consistent with the default gear module and number of teeth. By double-clicking on the gears, we can open their editing dialog. We can change the number of teeth on each gear, and the gear pair will update immediately. We can make either gear internal, provided it has more teeth than its partner. You can edit most gear parameters using this dialog: module, addendum, dedendum, root radius, even pressure angle if you're interested in special purpose gears. You can also edit the number of points drawn per gear flank. The more points drawn, the greater the impact on animation performance, of course. You can continue building mechanisms on the gear pair parts in a normal way, using parts and joints, gear pairs themselves, or any valid mechanism element. Okay, so now I'll show you how you can use gears to create sun-planet arrangements. In fact, the rules for creating gears allow you to pretty much create any gear construction you can imagine. We can add a gear pair to this arrangement. This time the driving gear will be attached to the base part. This line must be on a part that is kinematically solved. Next, we add a line on the driven gear. This must not be kinematically solved. This will become kinematically solved when we have added the gear pair. And finally, the center distance line. This must be kinematically solved. Remember, a kinematically solved part will be green, an unsolved one will be blue. And sure enough, when we cycle the machine, the driven gear, our planet gear, rotates around the sun gear. Next, I will show you how to create a solid gear from the gear pair, and also show you how to update the solid if the gear pair is edited and its shape changes. So we will stick with our planet and sun gear arrangement, but change the ratio to make them a little bit more interesting. Okay, what we have to do first we need the gear pair to generate a polyline of the gear profiles. So I press the Make Polyline button and then select the gear pair and hit OK. The gears turn black, or so it seems. Actually, the gear pair has generated two polylines, one for each gear, and drawn these over the top of the gear pair. Now, by adding a profile to the polylines, we can generate a solid. So I press the Add Profile button and select a polyline and hit OK. And if I then select the big purple box button, there's my gear. If we want to see the solids in the mechanism view, then as usual I need to hit the big purple Show Solids button at the top. And I repeat for the pinion gear. Okay, and there's that one. And then I've got my gears. And I spin the model and cycle it, and we can see the gears in mesh. Just a warning, the gears generate lots of vertices, and big gears with large numbers of teeth will take serious graphic card processing. So if you find your animations becoming jerky, then either reduce the number of flank points or buy a better graphics card. Okay, just to show you how you can rebuild your solids if you decide to change your gear ratios. I edit the sun gear and reduce the number of teeth on it. We see that our planet is burying itself in the sun gear in a most uncompromising way. This is because the gear pair is resolving as you edit it, but the solids are not updating automatically. You must do this manually. Press the Add Polyline button and then select the gear pair and hit OK. The solids should update. Finally, I will talk a little bit about gears and forces. Let's go back to the model that we started with. This had a straightforward gear arrangement, and so is possibly easier to understand with forces. As usual, before we can start using forces, we need to add some external forces to the kinematic chains. To do this, I will add a bob mast to the end of the driven gear part and turn on forces. The forces don't look very clear to me, so I can edit the colours using the Configure Power dialog shown in the forces tutorial previously. You can also stop displaying forces acting on specific parts just by unticking the checkbox. If you look at the contact point of the meshing gears, you can see the two equal and opposite forces acting on each gear angled at the pressure angle. Notice that as the load changes direction, the force vector also switches. So in summary, we have defined all the elements required to define the gear pairs, then gone on to create the gear pair, edit its parameters, its modules, addendum, gear ratio, number of teeth, etc., generated a polyline from the gear pair, and then added a profile to the polyline so that we could display a solid, and then seen how we can edit the gear pair and update the solid. And finally, we have shown how to generate force in gears and to identify the contact.